Alright, this is the last section for Chapter 5 for pre-ACE chemistry, electron arrangement in atoms. Pretty important section because it deals with when we get into bonding, because electrons is basically how different atoms are going to interact. So it's important to understand where they are and how they're arranged. So we're going to work with the Bohr model, and previously said that it's not a perfect model. It's a good start to chemistry, understanding the differences between the protons and neutrons and then electrons and their energy levels. So Bohr came up with his model that different number of electrons are in different energy levels around the nucleus. And basically it's helped us learn about the periodic table and its properties very nicely. So through experimentation, Bohr determined that the maximum number of electrons that can be held in each energy level is based on their size. So the first energy level holds 2 electrons, the second holds 8, third holds 18, fourth 32, and then back down from 18, 8, and 2. So you can see here, looking at the periodic table, we have hydrogen with 1 proton, 1 electron in the first energy level, and then helium with 2 protons and 2 electrons in the first energy level. And then when you go back down, down to the next level, you have 2 rings now. That's called the second energy level, and that's where you find the third electron, a lithium. And then so forth, it keeps adding 1 electron in each of the final ring. So for beryllium, it has 2 outer electrons and the 2 inner ones from the previous row. Okay, you keep adding more and more. Then you get to neon here. Again, it's in the second row still, so it only has 2 rings, 2 energy levels, and it holds up to 8 around neon. Then after neon, you get into proton 11, which you have is sodium. And you can see that it has 3 rings, and that means the outer electron has 1 electron, and then it goes to aluminum 3, and then so forth, continuing adding 1 electron each time as you go across the periodic table. Okay. Now, once you get to the transition metals, you start adding more and more electrons within the energy level, particularly the third one, because it can hold up to 18. So what similarity do elements in the same group share? They all have the same outer electron. So lithium, sodium, hydrogen, they all have 1 outer, we call valence electron in its energy level. It has 1 electron. The second group would have 2, and then a third group would have 3, and so forth. We call these valence electrons, the outermost shell of electrons of an atom. This is important because, like I said, it's going to basically how an atom reacts, and how they're going to bond with different things all depends on their valence electrons. So everything stems from here. So that's why it's important to understand how many electrons each atom has in its valence shell. So vertical columns, those are up and down, are called groups. And we'll get to the rows later on, those are called families. They all have the same number of valence electrons. So group 1 always have 1 valence electron. Group 2 has 2. Group 3 or /13 with aluminum has 3, and then so forth. Valence electron, again, electrons in the outer energy level of an atom. So here's your periodic table. Group 1, called the alkali metals, all have 1 valence electron. Group 2, called the alkali earth metals, has 2 valence electrons. Group 3, which is the boron group, all has 3 valence electrons. Carbon group has 4, nitrogen group has 5, oxygen group has 6, the fluorine group, which is called the halogens, has 7, and then noble gases all have 8. So, valence electrons. Can you figure out the valence electrons by looking at the group number on the periodic table? So, 1, 2 for alkali earth, 3, 4, 5 for nitrogen, 6 for oxygen, 7 for the halogens, and 8 for the noble gases. How many valence electrons does gallium have? So you look for gallium, Ga, that is in the boron group, so it has 3 valence electrons. How many does strontium have? Strontium Sr is over here, number 38. It's in the alkali earth, so it has 2 valence electrons. Xenon, xenon's a noble gas, so it's going to have how many? If you said 8, that's awesome. Alright, rubidium. Think about rubidium. Think about how many valence, what group it's in. It has 1. Arsenic. You gotta find arsenic, As. That's the nitrogen group, number 33. Has 5. Hydrogen. First group, 1 valence electron. That's why it's so reactive. Astatine, At. It's in the halogen group, so it has 7. Alright, so again, they all have the same number of energy levels around the nucleus of an atom. They're just not all filled. So, the first row, period, you call them, all has 1 energy level. The second period has 2. The third period has 3. The fourth period is in group or energy level 4. 5 is 5, 6 is 6, and 7 has 7 energy levels. So whatever row they're in, that's called the period. That's how many energy levels they contain. So horizontal rows are called periods, and elements in the similar periods have a similar number of energy levels. So remember, that's where the electrons hang out in these energy levels. So group or boron is in the second row, so it has 2 energy levels. So boron has the first energy level from hydrogen group, period, and then the second column has 8 total, can hold up to 8 electrons. Chlorine, you look to the row, it's in the third row, so it has 3 energy levels. It can hold up to 18 in that third energy level. Gallium is in the fourth, so again, you have 4 rings, 2, 8, 18, 32. Lithium in the second row, so it has 2 energy levels. Tellurium is in the 5th row, so it has 5 energy levels. Neon has 2 energy levels. Okay, periods and families. Periods are 1 through 7, those are the energy levels, remember that. And then groups go up and down, and that tells you the valence electron. So, iodine, number 53, is in group 7, so it has 7 valence electrons, and it's in the 5th period, so it has 5 energy levels. So families run down the table, groups have the same number of valence electron shells, valence electrons. So here is a little practice. You want to find the number of energy levels and the number of valence electrons for these 8 elements. Calcium is in the 4th row. It has 2 valence electrons. Fluorine is in the 2nd row, has 7 valence electrons. Aluminum is in the 3rd row with 3 valence electrons. Potassium is in the 4th energy level, right next to calcium, with 1 valence electron. Carbon is in the 2nd row, so it's 2 energy levels with 4 valence electrons. Phosphorus is energy level 3 with 5. Radon is in group 6 with 8 valence electrons, and hydrogen group 1, family 1, sorry, period 1 has 1 energy level, as in group 1, so has 1 valence electron. So drawing the Bohr model. So how does the Bohr model help us understand and help us kind of comprehend how many electrons we're working with and where they're located? So you draw, step 1 is to draw a circle to represent the nucleus, and inside the nucleus you write the number of protons and neutrons. And for the neutrons, we're going to round the weight by its whole number. So for example, strontium has 38 protons and its weight is 87.62. We're going to round that to 88 to keep it simple, and that means it has 40 neutrons. So you draw a circle with 38p plus and 40n0 or not. Group 2 is the correct number of energy levels. So you have to find the period for your element. In this case, strontium is in period 5, so you have 5 rings around it. Now we don't draw the whole circle because it can be a lot of space to take up, so we just draw like a little parentheses to represent a energy level. So we draw 5 little parentheses to the right. It has 1, 2, 3, 4, 5 because it has period 5. Alright, step 3 is to fill in the energy levels with the correct number of electrons. So you always do the last energy level first because we know exactly how many valence electrons it has because it's in strontium's in group 2. So we put a 2 at the end. Step 4, then we start with the first energy level and start filling the max number of electrons that can hold each energy level. Okay. So we know it has 2 in the first energy level. It can hold up to 8 in the second, 18 in the third, and then we got to figure out how many is going to be in the second to last energy level by doing some math. So you add up the number of electrons you have and subtract it from the total of electrons that you should, which will be the same as the per atomic number, because these are neutral atoms, so that means the protons and electrons have to be the same. So we know there's 38 electrons. We already put in 30, so that leaves you with 8 left over. So we put 8 in the second to last energy level. And that's the Bohr model. So what would the aluminum be? Aluminum is number 13 on the periodic table, so it's 13 protons. And we put 3 in the outer shell. We put 2 in the first shell. That gives you 5. So that leaves you with 8 electrons left over. Bromine is number 35 on the periodic table. So it's in the halogen group, so we know it has 7 valence electrons. Okay, you start with 2, 8, that's 17. That leaves you with 18 left over to put in the second to last group, the second to last energy level. Alright, so we're going to work on the Bohr model worksheet in class for more practice, but please review this if you have any questions.